All right, so this is a quick test on the xCloud. So we have an xCloud cluster running on Singapore region with you can see 30 CPUs and 2x large and large, a mix of these two node types. So if I go here on this console or on this UI, so we already have some stress tests running on this cluster. So if I'm going to check the tail latencies of the cloud, so we can see that this represents the P99. So this one is still well below 5 millisecond, if you can see. And if we go to the monitor, so let's open the monitor for this cluster. It should be running around 100K ops at this moment. Right, there you go. So it is indeed running 100K ops at the moment. So what we're going to do is we are quickly going to scale this cluster out to something bigger with 190 vCPUs. So that will give us 3 nodes of I for I16X large. And this should be able to support 1 million operations per second, which is what we are going to try. So this as easy as just setting the vCPUs that you want or horsepower that you want and then just save. So it is going to change here very quickly and then it's going to start the scale out process. So what we want to do now is I will open up uh, yes, so I will open up, I will keep this monitor running, and on the same side we'll watch it here, and also we are going to watch this UI if there's any impact on the latencies. So far the latencies are still okay, so still nothing above 10 milliseconds as such. So it is running 100K ops as you see here. Let's open up a stopwatch. And I am going to start the stopwatch just to keep an eye on how long does it take to actually scale this cluster out. So we are going to keep it here somewhere. Yes, so let's keep it like this. Okay, and looking at over here, we can start this uh, node status update. So this is going to show us the current nodes that are there in the cluster. So currently we see there are 6 nodes as we started, all are active. So as soon as the new nodes appear, we will know here immediately, even though the monitor will not show that immediately, but at least on this UI, because we are calling the Scylla Cloud API, so we'll know immediately when those nodes appear. All right, so roughly around 3 minutes, 15-second mark, we can see that those nodes are already added to the cluster. So they are currently joining, not really ready, but joining the cluster. Another thing we can quickly check is, let's stop this to check the progress. So this will call the Scylla Cloud API to see uh, what exactly is happening. So there's a resize request, and then this resize request is basically going to add 3 nodes and remove 6 nodes. So it's basically revamp the whole cluster. So existing 6 nodes will be gone, and then it will be replaced with 3 nodes, and all in the background. No disruption to the cluster, no disruption to the workloads that is happening here as you see here. So this one is just constantly running. Uh, Ignore this failed because this is something that is something lacking in the API right now, because this API was built for the normal Scylla cloud and then we are using it to query the Scylla X cloud. That's the reason why there's some discrepancy. So just ignore this part. But the other things are totally relevant. So at around 6 minutes and 20 seconds, we can see the nodes have already been added to the cluster. So by now, they should be streaming the tablets. So if I go back to the detail panel and take a look at this one by instance, So yeah, so they are currently streaming, they are currently rebalancing. So this will, uh, this one I think is still not refreshed. Yeah, there you go. So these new nodes are taking over. So they are going to pull all the tablets because they are bigger nodes. So the other nodes will eventually be gone. So if I go back to the detail panel, overview, sorry, because the nodes are being added, so there is some impact on the throughput. Hopefully we can see that here as well. Over here on the client latencies, we don't see any impact basically. So it is still doing the same workload. Not sure why this one is so low. Okay, anyway, so what we will do now is, so this will eventually stabilize back to 100k ops as the original planned throughput. So what I'm going to do is I am going to start or restart this stress test to target 1 million operations per second, because at the moment the streaming is still happening. So they are not totally balanced yet, but still we are going to push for that 100 million ops, and then we'll see how it stabilizes. So if you see here, the there are still 9 nodes, but we have almost touching 1 million operations per second. Yeah, so there you go. So 1 million ops per second with 17% load, and the individual node is also still very decent low. And on the latency side, the P99s are still like below 5 milliseconds. So this is wonderful. So now what will happen is if I go to this progress check one more time. Yeah, so this one is at 50% completion, so still happening. And if we look at the node status, so this is something that will constantly refresh. So you see that those 6 nodes are now leaving the cluster. So all this is happening, but you can see that there's very minimum to no impact on the latency, as you see here. So those nodes are leaving, those original 6 nodes are leaving, but the latencies are still rock solid. So they are very stable. There are some occasional maximum latency spikes, but looking at a normal client-side latencies are very low. So over here, this one is still running 1 million ops while all of those things are happening in the background. And if you take a look at the detail panel, yeah, so this node is already left the building basically. So the others will follow. So all those things are happening. As you know, the decommissioning is happening in a sequential way. So this thing is roughly around 10 minutes mark when the nodes started leaving. So that was around 10 minutes mark. So total 10 minutes to do all that. So now 6 nodes, 3 nodes have already left. So now we are left with only 3 nodes, and they will be leaving very soon. And this will be roughly around a total of 15 minutes journey, scale out from a very small cluster to a very large cluster that can support 1 million ops while running under heavy load. So all of these things are happening while still maintaining a good 1 million ops load. So this never changed. So now you see here, it is showing that some nodes are down, some nodes are unreachable. That's obvious because the nodes are leaving the cluster, and this one eventually will stabilize. And we'll get back to the 190 or so vCPUs that we configured in the beginning. So now we are left with just one node, a very small node, I for a large. All right, so there you go. So in around 13 minutes and 50 seconds or 40 seconds, we have a fully rebuilt cluster, starting from a very small set of nodes to 3 very large nodes. So considering this a complete rebuild of the cluster, while the latencies, if you see here, the P99 latencies, did not care at all, right? So they are running very smoothly. So that's awesome. And also this one was constantly running 1 million ops without any drop or any problem at all. So this one will stabilize in a couple of minutes time, because we are still checking the last 5 minutes. So in the last 5 minutes there were some nodes that were unreachable or inactive, so that's why it's still showing that. If I was to modify this to, let's say, 1 minute, this one I think should, yeah. So yeah, in the last 1 minute we still had 6 nodes unreachable, so hopefully it will stabilize very soon. And you can see here there's no impact on the latencies. All right, I think that's all I wanted to show. If let's say we want to go back, then again what all we have to do is come back here and update this number again to whatever number we want. Let's say we want to go back to 30 vCPUs, we just change it, and then the cluster will rebuild automatically.